All right, the stream will be starting momentarily, so thank you for joining. I'm just keeping notes of the different questions that we're going to be talking about. I'm also going to be demonstrating how to use the calculator. So we got a lots to talk about. The stream will be starting momentarily. All right, we're going to drop the time down to 5 minutes. We're going to be starting the stream in 5 minutes. All right, welcome. Welcome, everyone. Hopefully, you can hear me loud and clear. It is now starting, so welcome to this midterm review, and this is where you'll get all your questions answered. So feel free to ask questions in the chat, and as they pop up, I will answer them. I'm actually see a question right now. Question is, can we use our notes on the midterm? And I say absolutely. That is fair game. So prepare notes. Be prepared when you take it. It's one crack at it. So you definitely want to have notes. And on your notes, you might want to have formulas and just different key themes from different chapters. All right. So it is considered an open note exam. All right. Let me pull up some more things about what this test is all about. So first, let's what we can do is talk a little bit about first topic tonight is the practice midterm. First of all, some of you guys may not have took it. I understand that. Fine. Okay. So the practice midterm does not count for a grade, even though it looks like a real assignment. I'm going to underline this word, does not. So if so it's not graded, but the thing about it is it's there to give you practice to what the real thing will look like. The practice midterm might be harder than the actual test. So a lot of people are confused about that, and I do apologize that I wasn't clear and about the practice. All right, I wasn't clear enough. I did mention it that it was a practice that was just for a study guide, but I think a lot of people were thrown off by it. So it's actually closing tonight. You still have an opportunity to try to take it and practice it, but if you didn't access it by now and go through it by now, then you're kind of too late. It just will not be open anymore after tonight. And the reason is because the real midterm starts tonight. The real midterm opens up Wednesday at the stroke of midnight, and it will stay open all the way until Thursday midnight. So you got 48 hours to take the test, and I would expect you to take it sometime maybe Wednesday evening or Thursday evening, and that's it. You got one crack at it. All right, and the practice midterm was just there to give you confidence so you know what to expect. And sometimes in the past I would use a few problems from the practice. So the practice midterm acted like a pool of test questions, okay? And there was always one or two that might sneak in there. So it gives you an advantage. It's very advantageous for you to do the practice midterm and to listen to the videos. So as they say, knowledge is power, and this is true for my class, it's true in statistics as well. So if you made the effort to listen to this recording, then take advantage of what I'm saying. All right, so hopefully there's no other questions about that. I'll look and see what other questions about the practice midterm that. Okay, so yeah, that was a question. So it is not graded. It doesn't count for anything. So you doing it, you spend a lot of time on it, it will probably help you do really well on the real midterm. That's really the value of it. So it's not completion or anything. I don't look at if it's completed. I don't look at the scores at all. I don't keep tabs on who did it and who didn't. I don't. I just put it out there. Some people don't touch it at all, and they may get 100 on the midterm. Some people have done really well on the practice, and then they turned around and did really well on the actual midterm. Sometimes people will do bad on the midterm, and then I look and see, we try to help them and we find out what happened, and come to find out they didn't ever do the practice midterm. And if they did do the practice midterm, it probably would have helped them a lot more. So the practice midterm is just there, just to get you ready for it, okay? And I hope, again, I apologize for not being clear about that, but hopefully you did do it. And if you did do it, I think you are going to have a huge advantage for those that didn't do it going into the midterm tomorrow. So any other questions about the practice midterm? All right, some of you guys may have seen two different midterms, practice midterms. This is a mistake. Um, there should have only been just one practice midterm, and it should have said updated. That is the one that I go off of. The regular one is, I don't know, it probably, the updated one probably has all of the older practice midterm questions and then more, just to give you more practice. So if you did do one of them, hey, it's fine. But I mean, maybe you were logging in through Pearson and not through Canvas, because if you log in through Pearson, you may be able to see the other practices. And it's just there for extra practice, just more questions that you might encounter that you need to prepare for. All right. If you have the time, you can look at both. You didn't necessarily have to do them both, but you know, the one that says updated is the main one. So there are two different practice midterms. Now let's talk about the actual midterm now. So first of all, the time, it is 150 minutes long. That is, what would we say, 2 hours and 30 minutes. Plenty of time to complete it. There are 20 questions. And I'm going to give you a breakdown of where those questions come from. All right. So I'm going to give a breakdown of those right now. See if maybe through one from 1.1, two from 1.2, two from 1.3, one from 2.2, one from 3.1, 3 from 3.2. All right, hold on. Let's keep going through this. Two from 3.3. Two from 4.1. Three from 4.2. One from 4.3. And 2 from 5.2, and I believe that's the 20. Let's add it up. We got 1, 2, and 2 is 5, 6, 7, and then that 3 is 10, and 14. 14 is 17 plus 3 is 20. All right. So this is the grading distribution. A lot of teachers do not give this, and the reason is because we want you to study everything, and so that's one of the reasons why they don't do that. But I feel like I think that actually there's nothing wrong with giving you more information about it. All right. So that's pretty much all the statistics I have for the midterm. Let me just put the dates that it is open. So starting from 12/10/21 until 12. So you can okay. So it actually opens up later tonight at midnight. The midterm is open. All right. And then again, Thursday midnight at 11:59, it locks out. It's done. And this is the only time you can take it. I do not extend it. That's it. So you got to plan ahead on when you plan on taking it. Now, to do 20 questions, 230 minutes, that is an abundance of time. I don't think time is really going to be an issue for you. You're going to have an abundance of time. So that being said, that should help you prepare and think about what's required for this. All right. So any questions about the midterm exam and how it's going to go down? Okay, was that helpful so far, what we just talked about? I'm trying to think if there's any other things that might need to know. No. So it is I think it's all going to be multiple choice, just kind of the same way the quizzes have been, the same way the homeworks have been for the most part. Um, I'm pretty sure. So that's what that's all about. All right, so now one of the things I wanted to do was kind of talk a little bit about how to use the calculator on certain problems. There were students messaging me about some of the practice problems that use the binomial distribution, and they wanted to know how could they use their calculator to solve that problem. So I do have the answer for them. Pretty much ready to answer those kind of questions. So I have my calculator now, and I'm ready to use it. So what we can do now is kind of look at some problems from the practice, or even from some of the homework assignments, like from 5.1, 5.2, or 5.3. So if you guys happen to have some questions on 5.1, 5.2, or 5.3, we can do some of those. And then also, let's look at some of the problems from the practice. So this is the practice midterm updated. There's 35 questions. And again, you just hit start test. Now what I'm going to do is I'm not actually going to go through the test in this order. I'm just going to submit the test. And then what I'm going to do, now that I've submitted the test, as I review the test, let's go to review. I can pull down question help and do print. And then it will allow me to print the test with correct answers. So I'm going to print it, but I'm going to print it onto OneNote. So now we have all of the questions on the practice and their solutions. And basically now we can just write on this and work on some things that may have popped up, things that we were curious about. Again, questions like number 8, we will not do. So for example, okay, let me get that. So if I come in here, I'm going to X that out for you. Now, the reason why we're dealing with when it gives you the odds type of probability, like the 1 in 24 and things of that nature, we're simply not doing. And it just happened to sneak on here. It wasn't filtered out, but and it's probably not a very complicated problem to do. I mean, you just do 1 over 24 or whatever and get that. But we simply, those are the kind of problems that's not going to be on there. As far as like 10 and 11, I mean, I love these kind of table problems. Those problems are always good, and you really got to understand, how they work. Like, for example, let's just take a quick look at that one real quick. Let's say, for example, the data represents the results for a test for a certain disease. Assume one individual from the group is randomly selected. Find the probability of getting someone who tests negative given that he or she did not have the disease. So the individual actually had the disease. It turns out if I like circle this, these are all of the individuals who did not have the disease. Now if I add this up, I'm actually going to have 161. So it's 161 people. So that's why when they said given that he or she did not have the disease, they want you to use the total of the 161 and not the total of all individuals in the study. So now let's go back. It says find the probability of getting someone who tests negative given that he or she did not have the disease. So there were 142 that tested negative. Actually, wait. Find the probability of someone who tests negative given that he or she did not have the disease. So, okay, so I'm getting 142. They tested negative, but they did not have the disease. So, and this is the way it's supposed to work. Like, if you are negative, you are supposed to test, then you're not supposed to have the disease in actuality. All right. Um, so I'm getting 142 over 161, but let's just see what that probably turns out to be. It's almost 90%. So what I'm going to do is use my calculator to convert that number um, to a percentage. So let's just see. Let's just kind of shrink this down a little bit. And let's see what happens if we put in 142 divided by 161. And they want you to round it off to 3 places. So it's going to be 0.882. And that's it. So it worked out, okay? Now, you'd have to know that they were talking that I think the key to this problem as we reflect on this problem is to realize that they kind of subsetted the entire study. They didn't, usually it's out of everybody. Like it's find the probability that someone that doesn't have the disease tested negative. Then it's 142 out of the total number of people that took the test, which you'd add up all 4 numbers. But because it said given, it was a conditional statement, and it said given that he or she or the person did not have the disease. So that restricted us to only out of the 161 people that didn't have it, how many people, what was the rate of people who got the correct test? The midterm, okay, there's a question that just came in about is the midterm on Thursday or is it tomorrow? So the midterm is on both days. You have 48 hours to take the test. You can take it on Wednesday or you could take it on Thursday, but you can't take it on both days. You only can take it one time, and so you get to choose the best time for you to take it. It's not like, hey, be here 5 o'clock or you're done. You can't, or you are going to miss it. That's not what this is. It's you can take it on Wednesday. If that doesn't work out for you and Wednesday is a bad day for you and you're not ready to take it and you got a lot of other things that's going on at that particular time, then just do it on Thursday. All right. I think that to me the sooner the better. I like normally the students like to just hurry up and get it done so they can see what they got, and then it's nice to get it done quick. Don't wait until the last minute is scary. I mean, human behavior, people take as long as you give them. That's just a natural normal thing of human beings. If they say the deadline is in 2 weeks, people are going to wait 2 weeks. If so it's fine if you take it Thursday, but the problem is it starts to get a little scary when you don't give yourself that much extra time. Like there's a lot of things that can go wrong, and then you miss the boat. Like you could have a tech issue that Thursday, whereas if you plan Wednesday, um, you get it done and that's it. You have a day to spare, right? But if you wait till the last minute, like say 10 o'clock on Thursday, it's only going to be open for 2 more hours. So you can't make a single mistake. Everything has to go the way you plan. And that just adds a little bit more pressure. But let's get to where we can get to some of the binomial theorem problems. And again, one of these type, the pick 3 and pick 2 stuff, the betting, you're just not going to have, we're not doing in this particular class. So 13 is off. Here's a question. Find the mean, the median, the mode, and the mid-range for the data. Now, here's the problem. The data is Jersey numbers. Jersey numbers don't mean anything. They have no real numerical value. It's a decoy. Those numbers are used to look the player up or to look up their last name or something like that. It's a category value. So some numbers can be used as placeholders. Like sometimes if you're working in data and you're trying to manipulate data and you come across, say, gender or sex, and you have M and F. Sometimes what you have to do when you're working with data is recode that for 0 and 1. And the 0 might be male, 1 might be female, and that's what you end up working with. It's a code. The same thing with these Jersey numbers. They're a code to look up that player's information faster. They have no numerical significance whatsoever. And for that reason, that's one of the reasons why, okay, you can calculate the mean. If they want the mean of the numbers, fine. It's not going to have any meaning. If they want the median, again, put them all in order, calculate the median. Is there a mode? Is there a number that appears more than others? Maybe not. Find the mid-range. Well, you'd have to know what the mid-range is, all right? It's going to be the high minus the low, and then divide by 2. And then finally they say, what do the results tell us? And they're saying that because the Jersey numbers are nominal, which is one of the 4 levels of measurement, all right, nominal is categorical. It is not a numerical. It was ratio and interval were the numerical ones. But ordinal and nominal are dealing with categorical values. And so because they are nominal, their measurements don't tell us anything. Now, I am going to show you how would you actually calculate the mean and the standard deviation if we had this list. So one thing I'm going to do is enter all the data into my calculator. So what I'll do is go into list, so stat, and then edit. Now I already have lists in there, so I'm going to clear them out really quickly. I'm going to clear out L2 as well. So go to L2, hit clear, and then enter. That'll clear it out quickly. So now all I'm going to do is enter in all the data in there. So let's see some more. Hold on. Wait, lost the. Wait 1 second. All right, and okay. So we have 69, 60, 69, 64, and then 31. All right, so I have all 11 values. It's always a good idea to double check, make sure, you know, if you're going to make a mistake, it's going to be on data entry. So you're going to make sure that the data looks good, it matches pretty well. All right. And now I'm going to hit second quit to get back to the home screen. So now there's several ways. There's more than one way to calculate the mean and the median. Now, I'm going to show you probably the best way first, just so that we can just jump right into it. The best way to get the mean and the median, which will also give you the standard deviation as well, is to go into stat and then calc. And this is going to give you your one variable statistics. One variable meaning one column, right? Two variables is when we have a paired data like an X and a Y, and it's paired where you could graph it. But we have one variable. We just have one list. So this is going to give us all the data, all the statistics on our one list. One var stats is the go-to choice. And just hit enter. Now, I have on Stat Wizard. If you have Stat Wizard will tell you what to put in. It will prompt you. All right, what do you want your list to be? I choose L1. Frequency list. Do I have a frequency list? I don't. So I can leave it blank or just put in 1. It doesn't matter, but I would just leave it blank. Hit calculate. And there it is. The first thing it gives you is the mean. It gives us a whole bunch of stuff. It does give us the mean. It gives us the sum of all the numbers. It gives us the sum of all the squared of the numbers. SX is the sample standard deviation. So if our list is a sample, it gives us the deviation. If our list is a population, it gives us the deviation. This is the population deviation. Clearly, it's not a population. It gives us the total number, the min, and then the last part is the 5-number summary. If you scroll down, it gives you the minimum, the 25th percentile, the lower quartile, it's 31. The median, this is what we wanted, is the 50th percentile, 64. Then they give us the 75th percentile, which is Q3, the upper quartile, 79. And then the max number, 97. So the mean and the median is here using one var stats. Now, if you didn't have one Stat Wizard, I'm going to turn off my Stat Wizard. I want to go into mode to turn it on or off. Now, if it's off, it's not going to prompt me. I just have to know what to do. I have to know what to put in. So I go into Stat, Calc, one var stats, and it needs a list. I can put in L1. Now, if I had two, like a frequency list as well, then you do comma L2, the other frequency list. But I just have L1, hit enter, and there's all the information that I needed. So that's using the calculator, all right? There's always going to be just a few buttons to press in stats. We're always going to be using the same like 3 buttons. We're going to use stat a lot. We're going to use second distribute a lot. And between those two, it can carry you all the way through the course. Between the stat button and the second distribute button, or second vars, which is DISTR, distribute. It has all the statistical distributions in there. Those two are the go-to buttons that you really have to know and know where things are. Now, if you ever need something and you don't know where to find it, there's a catalog. You hit second catalog, and you just start scrolling down. You scroll down. It's in alphabetical order, so if I wanted something like D, like I want to turn off, or let's say I want to turn off Stat Wizard, I can click S, and then go all the way down to like Stat, ST. Let's see if I can find Stat Wizard. I could turn back on Stat Wizard by finding it in the catalog, selecting it, and now it's back on. So now what we're going to do now is look at, yeah, the open notes, and the book is fine as well. The book is great. I mean, it like supersedes the notes, you know. Um, Yeah, no, it's fine to ask questions. I'm looking for questions, so if you have questions, that's always a good thing. It lets me know what you're thinking about as well. So let's take a look at some more problems from the practice. I kind of want to get down to Now the variance, you're going to have to know what the variance is, right? The sample variance, which is basically the sample deviation squared. So you can find the sample deviation and then just square it. We don't really do this by hand. Okay? This is a box and whisker plot, and it is the 5-number summary. It highlights the minimum, Q1, the median, Q3, and then the maximum number on 192. So I did want to get into like 34, a problem like 34. So let's look at 34 for a second. 34 is one of those 5.2 questions, if my memory serves me correctly. It is one of those binomial probability density function problems. Now, there's multiple ways to calculate the probability, binomial probability. A lot of different ways. But I'm going to show you the way that it's done using the calculator. Okay? So first of all, you have to make sure that all the conditions are met, like the trials are all independent, and we're talking random and all that good stuff. Obviously, problem number 34, all the conditions are met for the binomial probability function. So we can use the binomial probability function to solve this problem. It's a yes or no type. It's a success or failure. 46% you either meet or you didn't meet. So let's read the problem. It says, assume that when adults with smartphones are randomly selected, 46% use them in meetings or classes. So they either use them in the meetings or classes, or they do not use them in the meetings or classes. That's how that success or failure. It's either, on or off. You're either yes or no, meeting or no meeting. So it satisfies the binomial probability function. So now it says, if 25 adult smartphone users are randomly selected, so that's our N. Find the probability that exactly 20 of them, so X is exactly 20, exactly 20 of them use their smartphones in meetings or classes. So that's exactly 20 out of the 25. There's a lot of different combinations of 20. So we know the probability is 46. But we don't know what it is going to be for exactly 20 when we've selected 25, which means 5 of them did not, but 20 of them did. We don't know what that probability is. So that's what we're going to try to figure out now. So we have all of the pieces. We have the probability of success that they used the meeting is 46%. We have the number of trials is 25, and then the exact amount is 20. And so these are the 3 components that you need in order to calculate the probability. So what we're going to do now is use the probability density function. So you can pull up our calculator. All right, I'm on the home screen. I'm going to clear out everything here. And the first thing I'm going to do is go to the distribute button, second vars. So we got a bunch of things already. This is chapter 6 and 7 stuff, but we're going to scroll all the way down. And there it is. We have 2. We have binomial PDF and binomial CDF. Whoa, they even gave us the inverse binom? Wow, this thing is updated. All right. All right. So we have binomial PDF and binomial CDF. For the exact amount, we have to use binomial PDF. We're not using the CDF, so you don't want to get those confused. The CDF is dealing with the cumulative probability. Like if they said, what's the probability of um, at most 20 use their cell phone? So that's probability of 0, 1, 2, 3, all the way up. We're not adding them all up. We just want the exact amount. So it's binomial PDF. We choose it. Now Stat Wizard comes on. Stat Wizard's going to prompt me and tell me what to put in. It tells me the parameters and in which order. How many trials are we working with? Well, that was 25. What was our probability? Well, the probability was 46. 0.46. Okay? You have to enter it in a probability between 0 and 1. And then the exact amount is 20. And now we would paste this onto the home screen. This is how you would enter it in if you do not have Stat Wizard. The first value is your number of trials. It should be the greatest number, the greatest number out of all three. The middle number is your probability, and then the exact amount. So this is the probability of 20. Hit enter. It is very small. Now someone might say, hey, it's 4.3. What? Probability is 4.3? Well, no, it's not 4.3. It's 4.39 times 10 to the negative 4 power. This is put in scientific notation because the number is so small. And we can check this if you want. If you don't believe me, which I know you believe me, but if you didn't, we could put a number in scientific notation. 4.3 e to the 4. Let's see what it looks like. Oh, that didn't help. What if I did 4.3 e to the 2? E to the negative 2, I meant. Here we go. So 0.000439 is this in scientific notation. So if they say round to the round the probability to the nearest 10,000ths, or 4 places out, it's going to be 0.0004, and that's exactly what they got. Round to 4 decimal places, and that's exactly what we got there. So that's how it's done. Now we're going to do number 35 as well. Okay, this is a spin-off of 34, but it looks like it's slightly different though. So we do need to understand what's meant by the word fewer and at most or at least. Those key phrases will throw people off sometimes, and so you have to be aware of that. Like at least meaning, well, let's do this one. Assume that when adults with smartphones are randomly selected, 51% use them in meetings or classes. So this time we're dealing with a different probability. Our probability of success, in other words, probability of them using it, is 51%. And you can type that in as for that. Now, this time are the number of trials, and each adult is independent, so it works. You can use adults as trials. N is 13. There's 13 adults randomized, and then the question is, find the probability that fewer than 5 of them use their smartphones in meetings or classes. So the word fewer than 5 you have to interpret that properly. Fewer than 5 actually means 4 or less. So mathematically, in symbols, I can write this as the big X minus 5. Now, that is equivalent to exactly 1 plus exactly 0, probability of exactly 0, plus the probability of exactly 1, plus the probability of exactly 2, plus the probability of exactly 3, plus the probability of exactly 4. If I were to take the probability of all these exact numbers and take the sum, I would get the probability of fewer than 5. This is painstaking, and there's a high degree chance of going wrong with all your calculations. So there's actually another way. For this, we will employ the binomial CDF function, and this is the cumulative density function. This will enable us to calculate all those probabilities in one fell swoop. From 4 all the way down. So let's use it. Let's go. So we're going to go back, and I'm going to show you where to go to get to the binomial CDF. Okay, so from the home screen, you're going to click on second distribute, and you're going to scroll all the way down, or actually you can scroll up. That's a shortcut to get down, and you're going to go all the way down to B. Okay, you could choose alpha B if you want. Select it. Now the number of trials we said was 13. The probability is 0.51, so about half. And this time our X value, because they want us to find the probability that fewer than 5, that doesn't include 5. So we're going 4 and down. We have to start at 4, and it's going to give us all the way down. Hit enter, enter, and I got 0.1183. And that's exactly what they had here, 0.1183. Okay. So just problems like that. I mean, just getting, doing the practices, making sure they work out, that you have clarity on them, you understand how they work. Some of the problems are very ambiguous. I will admit, they can get tough, but spend some time on it, rack your brain over it, and it's going to work out. Um, if you think about it, though, some of the practice midterm questions are pretty easy. They're not all that tough. 5 inclusive. Now what? Okay, so um, are you saying 5 and down or 5 and up? So sometimes they might say, hey, at least 5. So what if they wanted the probability of at least 5, meaning the probability of greater than 4, I could put, or you understand what I mean? If they wanted something like this, you could do 1 minus the probability of x is less than 4. That's the way it works. That's why they only give you the cumulative to the left. Because in order to get greater, if we wanted to calculate, let's see, let's say we had a problem and we wanted to calculate the probability of everything 5 and more, so greater than 4, at least 5. That's going to be 1, or the long way, it would be probability of 5 plus probability of 6 plus the probability of 7 plus dot, 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 all the way up and the dot, 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 because I'm running out of space, all the way up to the probability of 13. That's a lot. You see, 5, 6, 7, 8, 9, 10, 11, 12, 13. But the thing is that in a binomial distribution function, um, they all add up to 1. So the probability from 0 to 13 is exactly 1. So if I need to find from 5 all the way up to 13, all I have to do is do 4 and 4 all the way down to 0. Do the cumulative one and then subtract 1 from that. And that's the converse or the complement. Does that make sense? If you want 5 and down, then you need to include 5 in the binomial statement. So if we're doing 5, you would type in binomial. Instead of 4, you would just put 5, because the formula works for 5 and down. It wants to know the number you're starting with. So you would put in your trials, put in your probability, and then from 5 down, we're going to just put in 5. And this would be the CDF one. And that will work out for you. You shouldn't have any problems. All right, let's take a look at some of the table problems. There's a few here. There's 31, 32, and 33, all similar. Let's take a look at 32 real quick. So use the data in the following table, which lists drive-through order accuracy at popular fast food chains. Assume that orders are randomly selected from those included in the table. So I'm just trying to understand this for a second. So I have order accurate 330, order not accurate 39. B, order 278, order 57. C, 248, 30. Okay, good. D, okay. Order accurate, order not accurate. Yeah, you know, a lot of places are very inaccurate. I don't know what's up with McDonald's. Like, even if, like, they don't give you a straw, that's inaccurate. If they don't put ketchup, inaccurate. If they, any little thing that they did not do should count as an inaccuracy. I mean that. And that just, it irks me, you know, especially when you don't find out until you get home. I know a lot of people don't even eat McDonald's anymore, but it's still a good place, so we eat it sometimes. But it's really all about what you order. Okay. So anyway, I understand this table pretty well. This drive-through, order accuracy, okay, fine. 4 different popular places, fine. Here's the question. If one order is selected, find the probability of getting an order from restaurant A or C, or an order that is not accurate. All right. So there's an overlap. So if they just said A or C, oh, we would have been done. I mean, we could have just said, hey, A and C. The probability of A or C, we just need to find out the total of A and the total of C and divide that by the total of all of the restaurants, or all the people, all the orders, I should say, and we would be done. But then they threw in, not only are you going to find the probability of getting an order from A or C, but also an order that is not accurate. And so the number of not accurate results are these down here. Okay? And the problem is you do not want to count 39 twice. Because if we counted in A and we counted in C, we count 39 here, and we counted 30 in C already. So now to add up the other ones that aren't accurate, we simply have to add the 57 and 16. So what we're going to do to do this problem is, first we're going to do the A and the C, and then we'll do order not accurate, and then we'll subtract out the ones that are overlapped. And then we're going to divide by the total number of orders. Okay, so that's the plan. Okay. So A, if I add up A, there's 369 total. If I add up C, I'm just adding straight down vertically, 278. So there's A, C, 278, and then I add those together. Well, I'll wait for that. Now let's add up all of the not accurate results. 39, 57, plus 30, plus 16. So I've added them all up, but the problem is, I know this is kind of a long way to explain this, because there's a faster way to do it. The problem is I've added 39 and 30 twice. I've double counted these orders. That's not, you can't do that in probabilities. You can't, because that basically is going to throw off our probability. So what I have to do is subtract them out. So my long formula, let's start adding up some of these numbers because we're running out of space. 9 and 7 is 16 plus 6 is 22. 2 and 3 is 5 and 5 is 10, and that's 14. So all of that was 142 plus 369 and 278. Turns out to be 647. Now, because we're calculating the probability, I need to know the total number of orders. So we already know the total number from A, the total number from C, but what about the total from B? The total from B, if we add that up, $335. And what about the total from D? So C, D, let's do 120. Well, we could do this one in our heads. 140. So let's get the total number of orders. It's nice when they give you the total number of orders and you don't have to add them all up, but it's fine. We'll add them all up. Here we go. So we have 335, 140, 369, and 278. And now we're just simply going to add it straight down, okay? 17 and 5 is 22. All right, keep hitting that. 2 and 3 is 5, or the 6 and 4 is 10. 7 and 3 is 20, and 2 is 22. Okay, so that's just 22. We'll do 3 and 7, 6 and 4 is 20 plus that 2. And let's see here. 5, 6, 9, 11. So the total was out of 1122. Okay. 1122. 1122. But we have to subtract the ones that were double counted. So 39, 1122 minus 30 over 1122. So we're going to add up all of these. 647 plus 142. I'm getting 789 plus, or now minus 39. So that's 750. And then minus 30. 720. So 720 over 1122. I hope I didn't just lose you guys on that one. Let's check and see if that works. Let's plug it into the calculator. Let's see, 720 divided by 1122. They're giving us 0.6417, rounded off to 4 places. They actually wanted us to round it to 3 places this time. Yeah, that's the thing. You could have just added the 57 and 16 and to the total, and that would have worked out for you as well. I was just trying to be very textbook and instructive about it, but the truth is you're just going to add up all those numbers that you needed. Okay. Every number except 278 and 124. And so the probability is pretty high. In 60, anytime you're more than 50%, that's betting odds. 50% is really good. So you go to 64% chance of ordering from A to C or going anywhere and having an incorrect order. A 64% chance of probability of this happening. That was actually a really good question. That was a really good question. All right. Yeah, I think I touched on pretty much all the big problems. I really think you're going to be in pretty good shape. You're pretty much ready for it. Not much else really going on. I just maybe make sure there's any other questions that I'm missing that I didn't answer yet. There was a question on 5.2 homework that a question came in about someone just asked a question about a farmer. Let me zoom in so you guys can all see this nice and clear. All right, so this is the famous problem number 35. A pharmaceutical company receives large shipments of aspirin tablets. The acceptance sampling plan is to randomly select and test 39. So that's your total sample size. Your N is 39. Oh crap. I had the wrong thing. Let's go back. So our N is 39. It says, now the rule is if there is only one or none. So that means X could be 1 or 0. You have to reject. And there's a 4% defective rate. So we have P is 0.04. So what you need to do is find the probability of 0 plus the probability of 1. Or you could find the cumulative probability, binomial CDF of, again, the first number is 39, comma, probability 0.04. Let's write it here. 39, comma, 0.04, and then 1. And this is the sum of 1 and 0 put together. So you're hitting 1 and 0 at the same time, and you will get the answer. It will be a very tiny probability there. Now, you could do the exact amount for 0 and the exact amount for 1. So you'd have to use binomial PDF, and everything else stays the same. For exactly 1, you would just leave it 1, and then you would recall it, put in 0 for the probability of exactly 0, which isn't 0. I used to always think that, hey, the probability of exactly 0 would be 0. I'm like, no, it's a thing. Like, you know, you could not have any. There's a chance that that could happen. That's the quick way to show this. I did have this done in the video that I sent through email. It was one of the last problems that we did in that video. And so I worked it out kind of like what I did here. I didn't have a calculator, but this time you can use your calculator and you can solve that problem. Nice. I saw DOS got it. Sorry. Good job. So that was one of the main questions. All right, so on that note, guys, we're probably just going to wrap it up here. Thanks for watching this edition of our study group. The next time we'll meet again is to do the final. We're going to replicate the same process for the final. There will be a practice final that will not count for any points. It's not extra credit, but it is going to have about 35 questions on it, and it will be like a pool of potential questions, and it will give you a good way to review the material and get comfortable in that testing environment, because that's the way you'll be testing for it. And what we'll do is we'll have this type of thing where we come together and we'll do a bunch of problems together, and you'll have other questions based on the homework or any other questions that may pop up. But thanks for joining, you guys. I thank you for your time as well, from coming and joining me, and good luck on that midterm. You know the midterm, you'll know the class, no doubt about it. You guys have an awesome week, and we'll share out the results and the statistics of our results next week. All right, I'll share them out so everybody can see where they fell on that test. If you have any questions or comments or concerns or anything, feel free to reach out to me through Canvas, and I'll respond to you as soon as I get the message. All right, guys.